distance. First point. Next point. Already we discussed the time and distance, right? And in time and distance, we discussed some points that speed is equal to distance by time, distance is equal to speed into time, and time is equal to distance by speed. These 3 points already we discussed, and apart from these 3, we have seen some points like called relative speed. We discussed even relative speed. And we discussed some points called when time is constant, when speed is constant, when distance is constant, etc, etc, etc. We discussed so many points, right? Okay, this is one part that we have to understand, okay? Right, that is trend. But now we have to know the difference between time and distance topic and the trains topic, okay? See, doing the problems is not much difficult or not much bigger task, okay? But understanding the concept is much more important, right? And from the scratch you should start. So I'll start from zero, first point. Second point is I'll explain even the background behind time and distance, trains and boards, okay? What is the major difference between these 3 also I'll explain, okay? Right, first of all, time and distance and trains, I'm explaining the differences between these 2, and then regarding boards also to you, okay? These 3 points that I'm differentiating those 3, okay? I'm not explaining them, I don't want to go through them detailed. I'll differentiate them, okay? Suppose if you observe a point in time and distance, as a subtopic of time and distance, we discussed a topic called arrivals and departures, okay? In arrivals and departures, we discussed something called, suppose a train started here, okay, at Pune, another train started Delhi, okay, and the distance between them is something 1145 suppose kilometers, 1145 kilometers. A train started Pune at 7 a.m. with a speed of 65 kilometers per hour. Another train started at Delhi with a speed of 70 kilometers per hour at 8 a.m. So the questions will be like this: when will the 2 trains meet? That means the time at which they will meet. First question. Number 2, how many kilometers from Pune they will meet? How many kilometers from Delhi do they meet? Etc. etc. Questions we discussed clearly. But if you observe a point here, I used the word called trains. But by that time, I have not completed the topic of trains, but how I did it? First point. Number 2. Suppose, without discussing the concept of trains, if I can do the problems of train, then why should we discuss the trains concept again? These are the questions that I have in my brain. Okay. So the point we should understand is, so in train stop in here, what we will do is, we will take, so the train started here, other train started here. Is it correct? Both the trains met at this point. Is it correct? We will feel all are as a points only. Is it correct? We will never say that this is a train, it has a length, it started like this, it's a train, it started like this, both are meeting means they are coming like this. So this type of diagrams we have not drawn. How we will see about these questions is only, so here the train started, here the train started, they both met here. That means we are considering, even we are naming them as trains, but we are considering them as point objects. The reason behind it is, a train started means, so from the engine we will consider. Another train started means from the engine we will consider. They both are meeting. Meeting means both the engines will meet, right? That means engine is a point object, right? For us, engine. So that's why we won't think that a train has a length. Okay. Coming to a point, suppose observe a question. So I have a train whose length is 1500 meters. Okay. And this train is trying to cross a person. How much time it required to cross him if its speed is something 36 kilometers per hour? Okay, this is a question issue. Then what happens? Let us imagine the diagram for that question. Okay, first. So train's length is 1500 meters. Okay, this is the length of the train. This is my train. Okay. So crossing a man means man should be here. Okay, fine. The train has to cross him. Has to cross him means, suppose if it is a train. Okay, it is crossing me. That means what I have to think is its engine should be at my initial point, and crossing means ending point should be at me. Is it correct? That means initially the train is like this now. Now the train has to come like this. Okay, that means initially the engine is here. The guard compartment is here. Now the guard compartment is here, right? So that means how much distance it has to travel is 1500 meters, right? The distance traveled is nothing but the length of the train. That means here I am considering the length of the train. Is it correct? This is the important point that we should notice. Previously, we have taken a train also as a point object, right? But now I am taking a train as a lengthy object. It has some length. Is it correct? This is the difference between time and distance and trains. Means, sir, whether you use the word train, whether you use the word car, whether you use the word lorry, whatever it might be, I don't have any problem, sir. But only I have, the problem that I have is very simple. So, whether that object has some length or not, whether you are considering the length of that object or not, that is the important point, okay? See, suppose here I have considered it as a point object. That's why it surely comes under time and distance. It's not. It doesn't come under trains. It comes under time and distance. But sir, coming to here I am considering the length of the train. That means it comes under trains topic. Suppose tomorrow if he said that sir, there is a car. The length of the car is suppose 2 meters. It can cross a man in 1 second. Suppose. Then what is the speed of the car? That is the question he is asking. Then what I have to do is, sir, here I am considering the length of the car, sir. That means this car problem will also come under trains only. Don't say that, sir, it is car. Keep a separate topic called problems on cars, problems on buses, problems on lorries. Don't ask me, okay? Right, those all comes under a single topic called trains. That means if you consider the length of an object, then that is known as train stop. If you won't consider the length of an object, that is known as time and distance. Now, let us see what is meant by boats and streams, okay? Sir, in general, if you observe, in this topic, in general, what we will speak in our general point of view of time and distances, a man is moving with 10 kilometers per hour, a train is going with 90 kilometers per hour, or etc. will speak. Suppose if I said that a car is moving with 36 kilometers per hour, what is the meaning? So this is the road, sir. This is the road, sir. The car is here, sir. Okay, within suppose. Correct. Suppose this is the car with the, assume those are thighs, okay? Don't ask me the full-fledged diagram, okay? Right, assume that is the car. The car is moving, right? Okay, with speed 36 kilometers per hour. That means it is continuously, constantly going with the same speed, right? That is known as the point that we discussed so far. So that means it is trying to move with 36 kilometers per hour and it is moving with 36 kilometers per hour, right? Okay, this is the point we should notice. But sir, here nobody is pulling him towards his destination, okay? Or nobody is dragging him back to not reach its destination. Is it correct? That means nobody is either supporting or opposing, right? But let's come to a situation called like this. Sir, I'm not going in a village road, sir. I'm going in a national highway. All the national highways will never be flat, okay? So in general, if the village roads, if you observe, those are flat, right? But coming to national highways, all the national highways will be like this. There will be definitely some ups and downs, right? Okay. Now my car is here, sir, and it is trying to move with a speed of suppose 36 kilometers per hour. Now tell me, the car will definitely goes with 36 or it will definitely goes with less than 36? Less than 36. The reason behind it is, sir, there is a slope, upward slope. That's why its speed will be reduced. Sir, who is reducing its speed? Gravitational force. Is it correct? Suppose, sir, the car is here and it is trying to move with 36 kilometers per hour here. Now what happens is the car will go more than 36 kilometers per hour, right? The reason behind it is very simple. Sir, here, due to gravitational force, that force is pulling me down. That means pulling me towards my, goal. Is it correct? Object. That's why what happens is my speed will be increased. That means in this situation there is no case called somebody is supporting me and somebody is opposing me. But coming to this one, there is a chance, there is a point that somebody is supporting me and somebody is opposing me. This is the important point we should notice. Okay, right. See, since some opposition and some this is known as resistance, right? This is known as acceleration, right? This is known as resistance, that is known as acceleration. Such are available, right? In general, where those are available at more is, sir, a river is flowing, sir. Okay, I am here on a boat. And I am not trying to move in any direction. The river is moving in this direction with the speed of SR. Then what happens, sir? Even though I am not trying to move in any direction, I'll definitely move in the direction of the river, right? Suppose, sir, if I go in the direction of the river, then my speed will be increased. Suppose if I go against the river, then my speed will be reduced. Is it correct? So the point we should notice here is, when you are going towards the river, my speed will be increased. Against the river, my speed will be decreased. That means when you are climbing up, your speed will be increased. When you are climbing down, okay, then your speed will be increased. Right? That means this kind of situation. That means if somebody is opposing and somebody is supporting you, then that cases arrives in boats and streams concept. Okay, my dear boys and girls, hope you understand. Okay, see, for this we can take another example like this also. Observe a point. Right, suppose there is an escalator. Okay, there is an escalator. This is the escalator issue. Okay, so I am on the ground floor and I want to go for the first floor. Okay, first floor, and that's why the escalator is moving up. The escalator is moving up. Okay, then now observe a point. Sir, suppose here on a step, if I stand, then no need, sir. Automatically I will move up and I will reach my destination, that is first floor, right? Sir, suppose I am trying to move in the direction of the escalator, sir. Then what happens? Sir, I am also moving, the escalator is also moving, then speed will be increased, right? I'll reach the destination earlier. That means my speed is increased. That means my journey is supported by the escalator, right? Suppose. Sir, I am not at the ground floor, sir. Okay. I am at first floor. I want to come to the ground floor. But the escalator is moving up now. Actually, is it the right place to come up? No. But still, I am trying to move from first floor to the ground floor. That means which is opposite to the escalator motion, right? Then what happens? Sir, even though I try to move like this, sir, the escalator already moved up to this part, sir. That means I will be here only, right? That means even I will run a lot. I'll run with very fast. But my displacement will be very less. Is it correct or no? That means the point we should notice is the escalator is opposing me, right? That means this also comes under boats and streams only. Hope you understand. Okay. So now I'm clear cut differentiating all the three. So time and distance means the basic concepts, and the next point is if you feel all objects are point objects, number one. Number two, if the whatever the speed, that means if somebody is not opposing or not supporting, then that is known as time and distance. Coming to trains topic, sir, nobody will oppose, nobody will suppose, sir, in this topic. We will consider the length of the objects, that's it. Okay, whether it is a train, whether it is a platform, whether it is a whatever tunnel, whatever it might be, we will consider the length of the objects also. Coming to boats and streams, sir, either somebody will suppose me or oppose me, that is known as boats and streams topic. Okay. Alright, so this is a differentiation between time and distance, trains and boats and streams. Okay. Now I'm going to the next one called how we will deal the problems of trains. Okay. Right. Before going into the concept of trains, I'll explain a point regarding a small point called what is meant by relative speed. Okay. I don't want to go complete explanation regarding relative speed, because relative speed, if we discuss clearly, it will take half an hour. Already I explained in time and distance. Go through that. Okay. Now I am just giving the inputs what is meant by relative speed. Okay. Relative speed. Okay. Good. So anyway, whether they are trains or persons. Okay. Okay, observe, these are the cases. Sir, if you observe, in this case, a train is moving in this direction, man is moving in this direction. Or another situation, train is moving in this direction, man is also moving in the same direction. So two persons are moving in opposite directions from the same point. Two persons are moving towards each other from two different points. Okay, so two trains are moving in the same direction. Two persons are moving in the same direction from the same point, right? If you take any of this, okay, two objects are in motion. First point we should notice. So, two objects in motion. First point. Second point, that motion should start simultaneously. This is very important. Okay. That means when this train starts, simultaneously this train should also start. But if it starts at 10 a.m., if it starts at 1 p.m., then that doesn't work. We will never use the concept of relative speed. Okay? Right. If both are started moving simultaneously, then only we will take the relative speed concept. First point. So coming to the second point. Okay. So when two objects are moving, we will get lot of confusions that when he will overtake me, and suppose initially, suppose this is the point. Okay. Then that point is what do we say, forehead to me, right? So suppose if I run fastly and this is also running slowly, then after some time, so that point will be assumed here. Okay. Then I have already ahead of it, right? So previously I am behind of it. Now I am ahead of it, right? So suppose previously the distance between we both is suppose 1 kilometer. So after some time I have struggled. Finally I reached here. Okay. So that person is 5 kilometers apart. Suppose that means I am 5 kilometers ahead. Okay. Then what we should observe is two objects are moving. When I cross that object, when the distance is getting, so initially this is moving in this direction, I am moving in this direction, means the distance will be reduced, right? Reduced. But after some time we will cross each other, na? Then that will go that side, I will go this side. That means the distance increases, right? Sir, how can I understand all these topics? Okay, if I understand all these topics, my head will be heated a lot, right? That's why I don't want to go with all those things. What I will do is simply, when two objects are in motion, I'll imagine one object at rest. That is the most important point we should observe. Okay, one object kept at rest or imagined at rest. We should imagine. Okay, one object imagined at rest. Imagined at rest. So now the point you should notice is, sir, two objects are in motion. One object I imagine to be at rest. Then the other moves with relative speed. Okay. Suppose these two are moving, right? Suppose if I imagine this is at rest, then this train moves. It will never go with its own speed. It will go with a relative speed. Okay. But this is the point we should notice. Next point. When two objects are moving in same direction, relative speed is nothing but subtraction. Therefore, it is going with S1 speed. It is going with S2 speed. The relative speed is S1 minus S2 or S2 minus S1, whichever is greater. Okay. Suppose two objects are moving in opposite directions. Okay. Right. Relative speed is nothing but S1 plus S2. Okay. So, two objects are moving in opposite direction. That is the condition. But there is no rule that those should start at the same point. Those should start at opposite different points. There is no such condition. Suppose, okay, a person is moving in this direction, another person is moving in this direction. Both are moving from the same point, right? No problem for me. Okay, both are started moving simultaneously. Okay, and they are moving in opposite directions. The relative speed is nothing but sum of their speed. Suppose its speed is S1, its speed is S2, then relative speed is nothing but S1 plus S2. Hope you understand. Okay, what I am saying and how I am saying. Okay, this is known as the relative speed concept. Okay, now after knowing the relative speed concept, what we have to know is that after relative speed concept, we should know a few points about, yeah, right, we should know the basic formulas like, yeah, tell me, distance formula is speed into time. Speed is distance by time. Time is distance by speed. Okay, these are the three fundamental formulas that we have to memorize. Okay, always. And the next point, fundamental point we should memorize is 1 kilometer per hour is equals to 5 by 18 meters per second. And its reverse, that is 1 meter per second is equals to 18 by 5 kilometers per hour. Okay, to do the problems in the simplest manner, we have another point to memorize, that is 5 kilometers per hour is nothing but, sorry, not 5. 18 kilometers per hour is equals to 5 meters per second. Okay, my dear persons. See, by using this, we can do it in the air only. That means time will not be wasted a lot. Okay. So this is one point we should notice. Okay, these are the fundamental points. Okay. Now what I'm going to do is I'm explaining the concept of trains. Okay, in the trains, I'll explain 6 points, 6 cases. Don't feel that those 6 cases are the formula. Okay, those all are just for our utilization. What we say, to do them in the to understand the concept. That's it. Okay, those are not formula. I don't use them as a formula. After the 6 cases, I'll explain 2 more cases, but those 2 I won't explain directly. I'll go for the problems. In the problems, I'll explain them. Okay. Right now, let's see the cases. Right, see the first case. Suppose this is my train, its length is L, and it is moving in this direction with the speed of S. And here is a man. My question is, after how long the train can cross the man? Okay, so crossing means, already I explained that. Okay, so it's engine at the starting point now. Crossing means now the guard compartment should be at the person, right? So sir, now this is my train, right? This point is nothing but a pole, is it correct? Okay. So now we should differentiate a train and a pole. Sir, a train has a long length, sir. Suppose if you take sometimes goods compartments, goods trains, then it might be 1.5 kilometers to 2 kilometers even, right? That means the length of the train 2 kilometers means we should never neglect. We are unable to neglect. But sir, when compared to a train, suppose assume this is a pole, okay? The length of the pole should be considered, or we can omit it. Freely we can neglect it, right? That means the length of the pole is 0. That is the important point we should notice. So not only the length of the pole, sir, even if you take a length of the person, that is also 0 only. Okay, a tree, a pole, a stone, all are 0 only. Okay, right. I'm writing pole, tree, or stone. Sir, a pole and a man both are same or different? Some people will say that same because sir, pole's length is negligible, person's length is negligible, right? But there is some difference that a pole will never move, right? Suppose if it is a pole, if I fix like this, then it will be a fixed one. It will never move to the left or right or front or back, right? But a human being, sir, sometimes I'll go with this back, sir. Sometimes in this way, sir. Suppose if you go for the movies, Rajnikant will walk in the dances, right? That means what happens is there will be a motion. A human being will have some motion, right? Okay. So here that is the point. Okay. So speed, the pole or tree or stone, right? So here we can write as instead of a man at rest we can write. That means if the man is at rest, then we can treat it as a pole, right? Okay, man at rest. Okay. First case is train crossing a pole or tree or stone or man at rest. This is the heading that you have to take. Okay. I'm repeating. So, a train crossing a pole, a tree, a stone, or a man at rest. This is the first point. Okay. Now, what I want to do is, so crossing means the train has to come like this. Is it correct? Okay. Now, so here to here, this is the distance travel, right? Distance travel means you should take from engine to engine or guard compartment to guard compartment. Okay. Now, I am taking from engine to engine. Engine to engine means how much distance it travel? Nothing but length of the train. Sir, I know the distance traveled, I know the speed. What he is asking, how much time it required to cross it, right? So now I am writing time taken to cross. Time means, what is the formula? Here I have written. Time means distance by speed, right? Okay, how much distance it traveled? L. By speed, what is the speed? S. So time taken to cross is L by S. Khatam ho gaya. Okay. Right, now come to the second case. Okay, what's the second case? Is very simple. Suppose, yeah, here is a train. Its length is length of the train, that is LT. Now it crossed a pole, right? Pole doesn't have a length, right? So I was disappointed since the pole doesn't have a length. Now I'm taking a lengthy object, another one also. Okay, sir. This is my platform. This is my platform. Okay. Alright. So platform will definitely have some length, right? Suppose if you take Secunderabad railway station or Delhi, Mumbai railway stations, then the length of the platform will be 2 to 3 kilometers, right? So that means we should definitely consider the length of the platform also, right? Now this is the length of the platform. After how long, so the train is moving in this direction with a speed of ST or S. After how long the train can cross it, okay? If it is a situation, then what I can do is, sir, this is a platform, okay? Platform means it will never move, right? So that's why what I can take is, this is a platform or a tunnel or a bridge or a hill, because a hill will also will be like this, right? Hill, that means the train crossing, it means start here and go there, right? That means definitely it has to cross some length, right? That's why we will take a hill also as a platform, okay? Right. So another point, these all are motionless objects. Happy, sir? Sir, a train, if you take, a train may move, a platform will never move, right? That's why what I will do is, here I can write as train at rest also I can write. Train at rest. Okay, that is that one. Its length is how much? LP. Crossing means how much distance it has to cover is, sir, it should reach like this, sir. That is nothing but LT, right? So that means the distance it has covered is nothing but LP plus LT or LT plus LP. Okay. So distance to travel is okay for me, sir. Now he is asking time to travel the distance, right? Time means what is the formula? Distance by speed, right? Distance is LT plus LP by speed. Speed is ST. Okay, sir. Fine. Khatam ho gaya. Sir, now I have a question, that is, sir, you are always taking only one object's length. Sir, only one object is moving. Why don't you take both the objects are motion? Yes. Let us take it now, okay? Now we are going to the next phase, that is both the objects are in motion, okay? So, two cases so far we discussed, that is one point object when it is not moving, another one is a lengthy object, it is not moving. Now we are going to the next phase, that is a train crossing a moving object, okay? That too, again we have two cases, number one is point object, number two is lengthy object, okay? Now I am going for the point object, okay? Point object means, suppose this is the train, its length is LT or L. It is moving with a speed of ST. Okay. LT, ST. Okay. Alright. Okay. Now there is a man. That man is here. So now my question is, sir, man is there, man may move. So here we are discussing about moving objects. No problem, sir. Man is moving, I'm fine. But in which direction he is moving? He is moving in the direction of the train, or he is moving opposite to the train. That is important, right? So first, two cases again I will discuss. Okay, right. The first case is that man and train both are moving in the same direction. That means man is also moving in the same direction with a speed of SM. Okay, right? Not Kasam. Okay, it is SM. Okay, speed of man. Okay, now he is asking that what is the after how long it will cross the man. That after how long the train will cross the man. Okay. So now crossing, sir. Sir, here if you observe two objects are in motion, sir. Sir, previously I said that when two objects are in motion, we should imagine one object at rest. Is it correct? Okay, now I am imagining one object at rest. Sir, man's speed is little less, right? That's why I am keeping the man at rest. If I imagine one object at rest, the other moves with its own speed or relative speed? Relative speed. Sir, what is the relative speed here? Okay, relative speed means both are moving in same direction or opposite direction we should consider. Both are moving in same direction. Same direction means we should add or subtract? Add. So subtract. Subtract means ST minus SM. Okay, khatam ho gaya, sir. So speed is over, sir. Sir, he is asking about the time, right? If you want the time, we should know distance and speed. Sir, already I know the speed. So now we have to calculate the distance, right? Sir, now I am using the relative speed means I have kept already this man at rest. If I keep the man at rest, then my case is nothing but this is the one, right? That means it should come like this. Is it correct? The train has to come like this. Okay. Is it correct? The blue wala. That means the distance traveled is nothing but length of the train, L. Is it correct? Sir, I know the distance, I know the speed, then L by ST minus SM. Okay. This is known as time taken to cross a man who is moving in the same direction. Okay. You can take the heading as train crossing a man who is moving in the same direction. Okay. Right. Or another heading, that means another way you can keep the heading as train and man moving in the same direction. Okay. Alright. Now let us see the next case. Okay. Let us see the next case. Suppose this is my train, sir. Its length is L. It is moving in this direction with the speed of ST. Here is my man. The man is moving opposite to the train with the speed of SM. Okay. After how long the train will cross him? Okay. Same question, sir. But only change is both are moving in now in opposite direction. Okay. If both are moving in opposite direction, relative speed is nothing but ST plus SM because opposite means addition. Okay. First point. Number two. Sir, anyhow two objects are moving, sir. I'll keep one object at rest. I'm keeping him at rest. Then crossing means the train has to come like this. Is it correct? That means the distance traveled is nothing but the length of the train. Okay. Sir, I know the speed, I know the distance traveled. So time taken to cross is nothing but, okay, the distance traveled, that is L by ST plus SM. Is it correct? Right. This is the point we should notice. Okay. That means the point you should observe is, sir, by using relative speed or by the question, what I will do is, even two objects are in motion or one object at motion, okay, we will feel that only one object in motion. Here only one object is moving, right, in these two examples. Okay, coming to, in these two examples also only one object is moving, right? That means the point is clear for you, right? So always, whether even two objects are in motion, we will imagine one object at rest so that we will use the relative speed. That means we will take only one object is moving, right? This is the important point we should notice. Now see the next case. So now in motion I have taken point objects, right? In motion I am taking lengthy objects, okay? Now, this is my train, first train, its length is L1. It is my another train, its length is L2. Sir, it is going with the speed of S1, sir. Now coming to speed of second train, it is S2. Okay, fine, sir. But again the same question, sir. Both are moving in same direction or opposite directions. Is it correct? Okay, so no problem. Let us take both the cases. First I am going with, this is in this direction, right? The other also in this direction. Now you can take the heading as two trains moving in same direction. Two trains moving in same direction. Okay, always remember whose speed is more, that should be behind or lagging. Else, if suppose if this is the situation, its speed is more, then crossing will never happen, sir, because it's going fast, right? It is unable to chase it. Okay, there is no point of meeting or time taken to cross. There is no chance of crossing, right? That's why always remember whose speed is more, that should be at the back. Whose speed is more less, that should be at the front. Okay, right. After how long the train can cross it? Sir, anyhow two objects are moving, sir. I am keeping one object at rest. Okay, if I keep it at rest, Then the other moves with relative speed, right? Okay. Sir, this is L1, right? The distance traveled is nothing but here to here, that is L2 plus L1, that is L1 plus L2. Okay, distance traveled is clear, sir. So again here, two objects are in motion. Two objects are in motion means we should keep one object at rest, then the other moves with relative speed. That means what is the relative speed here? Both are moving in same direction, right? So difference, that is S1 minus S2. Okay, then time taken to cross is nothing but, yeah, distance traveled by relative speed, right? Distance traveled means L1 plus L2 by relative speed. Relative speed means both should be subtracted, that is S1 minus S2. Okay, this is time taken to cross it. Okay, my dear persons, this is the important point we should notice. Now, if you observe, both the objects are moving in the same direction, right? Suppose if both objects are moving in opposite direction, then let us see one example, okay? So this is my first train, its length is L1, it is moving with a speed of T1. And this is my train, another train L2, its length is L2 and it's moving with a speed of, sorry, not speed, speed means S, right? This is not T1, this is not T1. Okay, it's moving with S1 speed, it is moving with S2 speed, okay? Now the question is, after how long do they pass each other? Sir, anyhow, again both the objects are in motion, sir. I am keeping one object at rest. Then the other has to come like this, right? The first train has to come like this, right? Then the crossing is over, right? So that means how much distance it has to travel is nothing but L1 plus L2. Okay, no change, sir. So, and both the objects are moving in a opposite direction, right? So relative speed is also nothing but sum of their speeds, that is S1 plus S2. Okay. Now, what he is asking, time taken, right? Time taken to cross means time. What is the formula for time? Distance by speed. Okay, distance is nothing but L1 plus L2 by speed. Speed is nothing but S1 plus S2. Okay, khatam ho gaya. These are the 6 cases in general, that is 90% or 99% that will be given in the examination. Okay, suppose if the examiner wants to go very difficult, then he will go with the other range. Okay, now I'll show all the 6 cases to you. Observe this. This is the first case. First case means a train is crossing a pole or man at rest or stone or a tree, etc. Okay. Second one is a train is crossing a platform or a tunnel or a bridge or a hill or a train at rest. Okay. Right. Next case is a train is crossing a man moving in the same direction as a train. A train is crossing another man who is moving in the opposite direction of the train. Okay. Next case, 2 trains moving in the same direction, 2 trains moving in the opposite direction. These are the 6 cases that is most important in trains and trains topic. So remember that these I will never use any of them as the formula. Okay, whenever it is required, I will derive them and I will use it. Okay, this is the important point that you should notice. Okay, and the next point you should notice is now we are entering into the problems. But while we are doing the problems, I'll give a situation where the 6 cases are not directly used. Okay, it will become indirect sense. Okay, now let's see the next. Let us see the questions on it. Okay. Right, these are some important points that we already covered. Right, time, distance and speed is a relation between them. Distance is equal to speed into time. Distance is equal to speed into time. Time is equal to distance by speed. Speed is equal to distance by time. Okay. Conversion of units, when we convert kilometers per hour to meters per second, we multiply by 5 by 18. That is 1 kilometer per hour is equal to 5 by 18 meters per second. And when we convert meters per second to kilometers per hour, we multiply with 18 by 5. That is 1 meter per second is equal to 18 by 5 kilometers per hour. I already said clearly that 5 meters per second is equals to 18 kilometers per hour. Okay, this is very important point that we should notice. Okay, whenever it is helpful for me, I'll use like this only. Okay, I don't want to go with the regular one. Okay, so the next. Yeah, now we are entering into the problems. See one by one. Okay, see the problems one by one. See the first problem. A train traveling at 30 kilometers an hour. 30 kilometers an hour means, what is the meaning? 30 kilometers per hour. That means speed is equal to how much? 30 kilometers per hour. 30 kmph. Took 13.5 seconds in passing a certain point. Sir, observe a point. Here it is in the form of kilometers per hour. That means time is in the form of hour. But here he said that time taken to cross is nothing but in the point of view of seconds. 13.5 seconds. 13.5 to means we can write it as 27 by 2 seconds. Okay, right. So passing a certain point, sir, this is very important. It is not crossing a lengthy platform, it's crossing a point. Point means point object. Okay, that means like a pole, etc. Like a pole, etc. means, right, this is the diagram, its length, I don't know, sir. Here is the point, it is crossing. Crossing means, this is the situation, right? The distance traveled is nothing but the length of the train. Okay, fine, sir. Now what is asking, find the length of the train. Length means distance traveled, right? Because this is the distance traveled, right? Right, distance traveled means what we have to do, speed into time. Okay, length L is equals to speed into time. What is the speed? 30. What is the time? 27 by 2. Sir, here I have a question, that is, sir, it is in terms of kilometers per hour, it is in terms of seconds, means I should not multiply directly. Options are in terms of meters, right? Not in terms of kilometers, right? That's why I am converting the kilometers per hour into meters per second. To convert that, I am multiplying with 5 by 18. Okay, into 5 by 18. Okay. Now let us start simplifying. 9 threes, 9 twos. Okay, 2 ones, 2 15s. Okay, now multiply 15 5s are 75. 75 3s are 225. So 225 by 2, that is equal to how much? 112.5. So what's the length? 112.5 meters. That is option is third option. Okay, hope you understand. See, that means if you observe, I am not used any one as a formula. I am redrawing the diagram and I am explaining clearly. Okay, let's see the next question. A train running at the speed of 60 kilometers per hour crosses a pole in 9 seconds. What is the length of the train? Same question, right? So this is my train. I don't know its length. This is the pole. Crossing means the train has to come like this. That means the distance traveled is nothing but the length of the train. This length is equal to speed into time. What is the speed? He specified 60 kilometers per hour. So I am converting it into meters per second. That is 60 into 5 by 18. Okay, this is the speed into time. What is the time? He said crosses a pole in 9 seconds, right? So it is in 9. So then answer will be in terms of seconds. 9 ones, 9 twos, 2 ones, 2 30s. 30 into 5 is equal to how much? 150 meters. Not have it. 150 meters. That is option is fourth option. Okay. Right, now let's see the next question. A train length 500 meters long crosses a pole in 8 minutes. What is the speed in train? Sir, what is the difference between these two? Sir, here a train is crossing a pole or point object. But the point is, here the length of the train is unknown for you, speed is known for you. Coming to here, length of the train is known for you and speed is unknown for you, that speed is required. No problem. It's the same question, right? So what is the length of the train? He specified 500 meters. Okay. And now, this is the man. Crossing means like this, right? Okay. The distance traveled is nothing but 500. Okay. He is asking about speed. Speed means distance traveled by time, right? So 500 by time. How much time it require? 8 minutes. Sir, it is in terms of minutes. Options are in terms of kilometers per hour. It is in terms of meters, right? So that means, first what I will do is, we can do directly meters into directly kilometers. That means by dividing 1000. Minutes to by dividing directly with, what do we say? By 60. You will get hours. Or else what I will do is, it is in terms of meters, right? This 8 minutes I will convert in terms of seconds. That is 8 into 60 seconds. Then its speed unit will be in terms of meters per second, right? But we require in terms of kilometers per hour, right? To convert that, what I will do is, I will again multiply with 18 by 5 because meters per second is now converted into kilometers per hour, right? 18 by 5. Then the problem is over. Okay. 0, 0 cancels, 5 ones, 5 tens. Okay. Now, 6 ones, 6 threes. Okay. 10 into 3 is how much? 30. 30 by 8 means 15 by, so 30 by 8, right? No. That's 30 by 8, okay? 30 by 8 means how much it is? 15 by 4. I'm cancelling with 2. 4 threes are 12.75, 3.75 kilometers per hour. So answer is which option? Third option is the answer. Hope you understand, okay? Right, now let's see the next question. A train of length 240 meters crosses a pole in 24 seconds. What is the speed of the speed in kilometers per hour? Okay, similar question, right? Length of the train is 240. Okay, and it is moving in this direction with the speed of s, right? Okay, crossing, this is the man assume. Crossing means this is the situation of the train. The distance traveled is nothing but the length of the train itself, right? 240. Okay, now 240 by time. How much time it require? 24 seconds. 24. This is in terms of meters. This is in terms of seconds, right? Okay, this is nothing but the speed. That is equal to how much? 10 meters per second. Now you can, options are in terms of kilometers per hour, right? You can convert the meters per second into kilometers per hour in two ways. Number one, so 10 meters per second means you can write directly 10 into conversion, right? So 18 by 5. 5 ones, 5 twos. That is equal to 36 kilometers per hour. Yeah, this is one way, and most other people will do like this. So answer second option. Some people like me will not do like that. What they will do is, sir, 10 meters per second, sir. We know that 5 meters per second is equal to 18 kilometers per hour, right? Double means 36 kilometers per hour. Okay. So by seeing this, they will directly give the answer 36 kilometers per hour. Okay. So answer the second option. Anyhow, hope you understand. Okay. Right now, let's see the next question. A train passes a pole in 15 seconds and passes a platform of 100 meters in 30 seconds. Its length is. Beautiful question. So this also we can work out in two ways. By seeing, I can know the answer is directly 100. Directly 100. Okay. First, let us go in the conventional manner. Later, how I answered 100, I'll explain you. Okay. Suppose this is a train. Its length is L, I'm assuming. This is the platform. Okay. So this is a pole. It is crossing the pole in the span of 15 seconds, right? Crossing a pole means the train has to cross its own length. Is it correct? That means its length is L, okay, and its speed is 15, right? This is nothing but the speed, okay. Now what happens? This is the train. Its length is L. It is crossing a platform. Its length is 100, okay. That means crossing means the train has to come like this. That means the distance that it has traveled is nothing but L plus 100. How much time it has taken now? 30 seconds. Means by 30. This is nothing but the speed. Anyhow, in both the situations, the same train is moving, right? That means the speeds are same. Speeds are equal means equate both. So what you will get is, I'm writing here, L by 15 is equals to L plus 100 by 30. Okay. That means these two. This part and this part I'm equating. Okay. Then what happens? So 15 ones, 15 twos. If you cross multiply, 2 times of length is equal to L plus 100. Length is equal to how much? 100 meters. That means the length of the train is how much? 100 meters. So which option is the answer? Second option. This is one way to do it. The other way is, sir, here the same train is moving means the speed is constant, right? Here it has taken 15 seconds and here it has taken 30 seconds. That means time is simply doubled, sir. Okay. If the time is doubled, then distance traveled will also doubles. So previously it traveled 100 meters. Now the distance traveled will become 200 meters. So in this situation, 200 meters is the distance traveled means this is 100, this is 100, right? So the length of the train is 100 meters. This is the way that I answered it. Okay, my dear personals. Hope you understand. Okay. And now let's see the next question.